Yo, what's up everyone? I'm Harth. Welcome to day 1 of 15 days, 15 smart contracts in Solidity. Every day for the next 15 days, we are building one smart contract using Solidity or Foundry, from using the simplest of logic to building some crazy DeFi stuff down the line. Let's get into this. So I have made this sort of a umbrella diagram which explains what type of tech are we tackling today. Just a brief insight. I'm assuming that you know what Web3 is, what blockchain is, and that's why you're watching this. But if you don't know, let me give you a quick overview and you can research it into later. So blockchain is a decentralized network, and there are multiple type of blockchains. The one that we will interact with is Ethereum. It is invented by Vitalik Buterin. Now, what did blockchain named Ethereum bring on the table? They brought something called smart contracts, which are pieces of code deployed on blockchain. Now, what is this jargon called Foundry? Foundry is basically a development toolkit, which we can see here. So this crazy person is the forger in the Foundry. Basically, it's very mining term, mining blockchain, everything connects here. And this is Foundry. So it is a smart contract development toolchain. Foundry manages the dependency, compiles the projects, and run tests, and lets you interact the chain with command line and via Solidity scripts. So what is a smart contract and what are the stages of smart contracts? So let's get started. Smart contract, this never gets aligned. Now there are three stages in a smart contract as I see it. So first is writing the code, second is testing the code, and third is deploying the code. Now you interact with this deployed code and that is completely on you. So today we will focus on stage A and stage B. Testing is something that you need a little insight of how to write a contract and then you can get into testing. So let's start. So how to install Foundry? Basically, it's very simple. If you're on a Windows machine, you should use a virtual machine Ubuntu because it's very good supported. I'm in a Mac, so I'll be just copying this command. I'll just boot up a terminal, paste the command. It's already installed in my system. So let me run the Foundry up command to install 4 tools. Basically, let me give you insight on the 4 tools that are provided by Foundry. It's called Forge, Cast, Anvil, and Chisel. Now, what does Forge do? It lets you deploy your contract, run scripts for deployment. Cast. Now, what does Cast do? Cast actually lets you interact with contracts using CLI. Then there is Anvil, and then there is Chisel. Anvil is basically a little blockchain node running in your own system, and Chisel is what exactly its name means. It means you chisel the data, you encode, decode data using Chisel. That's very high level understanding of it. There is a lot more you can do with Chisel. Now let's spin up a folder and let's call this 15 days, and let's make a folder called 15 day 1. So let's go to day 1. Now one good habit of creating or working in Web3 is you have to read the docs. There are no good tutorials. That's why I'm making one, by the way. So the command to init a Forge Foundry project is forge init. So let's run this command. Okay, let's go to the IDE first. I'm using cursor. Basically everything is supported in VSCode or your any favorite IDE. I guess this makes my screen a little more visible. Now what does forge init do? It gives you 3 folders: script, src, and test. src contains your main contract file, script contains your deployment scripts, and test contain your tests. What we will do today? Now what is our primary objective today? Our primary objective is to make a bank smart contract. Now, like every other contract, these contracts are nothing, just some piece of code with some type of functions that are callable. There are access modifier. Basically, I'm assuming that you have understanding of how a programming language works, what are the components of a programming language, like interfaces, errors, etc. So what will this have? This bank contract will have four functions: deposit, withdraw, check balance, and transfer. We will come to this transfer function later. Let's just spin up these three functions first. Users will be able to deposit their money in the smart contract, withdraw their money. If they have deposited in the smart contract, then they'll be able to withdraw it, and they'll also be able to check how much balance they have in this bank. Okay. Ideally, there should be a function for opening an account, but we don't want users to fill up a form. So we are not going through that process. So let's go. The first step is to delete these three files. Let's delete these and let's go here and let's go for a bank.so. Oh, what's the error here? Nothing. Okay. Now I'll explain how to write a contract as we go, so you do not have to go into depths of reading documentation and stuff. So the first thing that we write here is SPDX license identifier, which is MIT. Now what does MIT means? It's open source. There are multiple type of licenses that you can have in this, but the one that we're going with is MIT. I mean, you can steal this code, I don't mind. So the next thing that we do is we give what version of Solidity are we using. So we'll be using 0.8.25. I guess the latest Solidity version is 0.30, but we'll go back and we'll use that. Let me destroy the terminals that are running in background. Okay. Now I have my Copilot turned on. I would not tell you to not use AI in this generation where everything is getting done by AI, but do not completely rely on it. Rely on Google, rely on Stack Overflow to solve your errors, debug your errors first. And if there is no way out, then you can go to AI and find your solutions. So now we know which functions do we want. The first function is deposit. The second function is withdraw. The third function is check balance. Okay, these are the three functions that we need in this. Now for every function we have to write if they are public or private. Yes, the deposit function is public. Yes, the withdraw function is public, and yes, the check balance function is also public. Okay, now we need something that is by default a data type in Solidity. It is called mappings in Solidity. So what are mappings in Solidity? Basically, they are hash tables which store key value pairs. So we need something here. Let's say Hard has stored uh, 5 ETH. I wish I had this much. So Hard has stored 5 ETH. X has stored 1 ETH. So basically, key value pair data structure where we know that which user has how much amount of money against their name. So Hard has 5 ETH, X has 1 ETH. This is called the account mapping. We'll name it like that. So let's create a mapping. So now mapping needs the data type that is being mapped and to data type that is being mapped to. So the first data type is address, is everything in Web3 is an address, and we'll call this, it will be a private, or it can be a private. We don't want let people know how much other people have. Let's call this account balance. Is cool. Okay. Now, deposit function. What will deposit function have? Deposit function will have an amount. Okay. Now, what will happen? We need to check if someone has deposited as much amount as they have called the deposit function with. So let's say I'm calling the deposit function with 5 ETH, but I'm depositing only 3 ETH. So we need a few errors. So let me give you a contract structure. So we'll have variables here, and then we will have events. Okay, events are basically when a task is accomplished, what do we do? and then we will have errors. So the first error will be deposit mismatch. This is very basic level of contract. There are better ways to handle things here. We actually will never need this amount function. We can directly call how much this message has. Now another thing would be, oh, we'll make them as we go. So let's just check if amount, oh yeah, the amount cannot be zero. Error amount cannot be zero. Okay, cool. If amount is less than zero, we will revert account amount cannot be zero. Amount is not equal to message dot value. We'll revert this with deposit mismatch. Now, wait a minute. What is this message dot value and why is has a red squiggly beneath it? Now, a message dot value. So basically, every function is called as a message. Now, as on a simple basic level, this is a message. I'm very zoomed in. So this is a message. Right? Yes, this is a message. A message has a sender, message has a value. Let's keep it till that. Sender is the person who has sent the message, so we can get their address from this, and value is money, that is ETH sent. Okay, now any function that takes some amount of money has to be marked as payable. So this function is public payable. All right, cool. So now this red squiggly will go away because message.value now has a payable map to it. And now what we will do, we will just make a mapping where we update the account balances which with the message.sender, that is the address, and we will increment it to how much balance does he have. Now what we will need now is an event that deposit successful. Exactly, and we will emit this event that deposit was successful. Okay, now let's come to withdraw. Now withdraw also needs how much amount that is needed to be withdrawn from there. Okay, now let's say a user has 5 ETH. Okay, let's say user has 5 ETH, so they cannot withdraw any amount that is greater than 5 ETH. So we need an error here. Error are basically your functions that prevent from contract to fail. So they are like your fail safe loops, which do not let the faulty code execute and it stop them right in their tracks. So now there is this error insufficient funds, which will say that they do not have enough funds. So let's say if account balances message.sender is less than, cool, so their account balance is less than their whatever amount that they have put in, whatever entry that is against their balance. Okay, now what happens is we go a message.sender, we actually remove them from the mapping and we decrement their amount. Now this is something that is very good to go and search. So as message.sender.call, this is a very informative function. Basically this is another source where you can solve your errors. So message.sender call, what does it do in Solidity? There is a very good answer here. It would be a withdraw function. It will be calling a smart contract for doing something. Okay, basically this is not safe, but for now let's forget that the world is a bad place and people are here to steal your money, and let's assume that everything is good, everything is fine here. So what we will do is bool success and will be message.sender dot call value amount, and if the deposit fails we will have an error which will say withdraw failed. So if not of success, revert seconds of damn revert with withdraw failed. Okay, that is cool. And we'll not emit this, we will emit withdraw successful. See, that's why we cannot always rely on AI. It emitted the same event for both withdraw and deposit, right? Let's go to withdraw successful, and the data type will be address and then the amount. So we go here and we emit withdraw successful. Now let's see what the check balance should do. Check balance will take an address of user, and it will return u1256. Basically, you ensure that the return type is written here, so that your function knows that what it has to revert or what it has to return. Basically, if you have written C++ code or anything, you'll know this. And now let's go and see what we have to return. So we have a mapping called account balances, and we have to just return the value that is against that account balance. Okay, so let's just put a check called user address is equal to 0. That's not what we actually need. We need an error which says account not found, and then we will use this here, which will be if account balances of user is equal to 0, revert account not found. Now, is this true? Think about it. That if someone has been here and if their account balance is 0 rupees, I mean 0 ether, then the account will exist, but it will have no balance. So we'll need to change the withdraw function now. So after we are withdrawing, if the account balance is 0, then we delete the sender from the account. So if they have 0, then they are removed from the bank. Very fun bank part of. Let's go. Okay, so this is a view function, as it just returns something. Now unnamed return variables can remain unsigned, can exist, whatever, and we return. Now as it's returning, it cannot be a view function, or can it be? Nah, yeah, it can be a view function. Basically, view functions are some type of functions that do not actually modify any state in the contract. What does state in the contract means? It means these mappings, these balances, nothing is getting updated in this check balance function. Okay, now I think we have written a good sort of smart contract. Now let's try to deploy this. Now, as I have said this, that in Foundry, you get a tool called Anvil. Now let's read about Anvil. So Anvil is a fast local Ethereum development node. So whenever you use Anvil, you get this kind of sort of things which you can use. Let's see, Anvil, and boom. Let me spin up the terminal, and you see that we have 10 accounts. So basically 10 addresses with 1000 ETH and the private keys for them. Now for deployment, the first and foremost thing is we need a .env. Oh shit, I expect that. We need a .env. Now what does .env need? We need an RPC URL. What does RPC URL consist of? It is basically your endpoint or the network access. Well, I'll make a video about explaining RPC URLs. For now, just think of this as an endpoint where your blockchain is working. Okay, so Anvil is listening on this endpoint, and we put that in. Now we need a private key for deployment. So who's going to deploy this bank? This guy is going to deploy the bank. It is the 0th address here, and I guess that's all we need for the deployment. All right, now let's spin up a new terminal, and I hope you are able to see the screen. Let me check if you are able to see the screen well. Yeah, everything is visible, right? Because the commands can get little small. Okay, so now we have forge, and then we have create. So let's read about Forge create. Let's go to Forge and let's see what is Forge create. So there is first Forge build. So let's go back and let's build our contract and let's see if we have any errors. No, there are no errors. Now the create script goes like this. So you write Forge create and you can go for help. So it gives you everything that you need. So it needs an account, it needs wallet options, it needs an RPC URL, it needs value. Value is when you want to pass some money to the function, basically call a payable function. Okay, so let's go back and let's run the script. But before that, running that script, we'll have to load these env into the command line. Basically, if we do echo RPC URL, we will not see anything printed here, right? So we will have to source this .env here. Now when we do this, we see an RPC URL spin up here. So let's run the Forge script now. Where is our contract? Bank.sol. What is our contract name? It's bank. Private key. The person deploying it is called private key. RPC URL is also RPC URL. And we put this broadcast flag just to get the address of the deployed contract. Let's keep it simple for now. I'll explain every flag when we go into depth of how Forge is working, how our contracts actually getting deployed, what is a testnet, what is a devnet. Oh, I think I should explain what is a testnet, what is a devnet. So basically, every transaction on a blockchain is paid. Okay, you cannot deploy a contract for free. So for developers, there is something called devnet or testnet. Devnet testnet has tokens, but it has no value. So basically, even if you can hack into these accounts, you will not get 1000 ETH worth of money. It will just be random tokens, which hold no money in real value, real world, no value in real world. Okay. So if I run the script, I'm not sure what's gonna happen, but it's the first video, so let's go. So we get a deployed to address, we get a transaction hash. Now, transaction hash is something which is called your receipt. This is where your contract is. Contract address is equal to this. Okay. So if you want to interact with this contract, you will have to use this address and then call the contract. Okay. So let's now run this. Now source.env. Now what was the first function? First function was deposit. Okay. Now we will use this account. So the private key for this is, now let's use depositor. Depositor, let's keep it short. And let's run source env again. Now how do we call a function? This is where cast comes in. Cast send contract address. This is where we are sending. Now what function are we calling? We are calling deposit and u into 56. This is the function signature that we're calling. What is the parameter that we are passing? Let's deposit 5 ETH into these. Okay, let's deposit 5 ETH. And we are calling from a private key of depositor. Let's go and do that. Depositor on RPC URL. RPC URL also suggests which type of connection you are on. Are you on testnet? Are you on mainnet? So this will change if it is a mainnet. Now I know that this function is failed and let's try to debug this. Okay, so we have this custom error. Okay, and the data is this. Okay, now how can we decrypt this? Now we can go and we can find what this error means, but let's try and see what is the problem here. I told you about the value flag, right? And let's go and see where the value flag is. Value flag, ether to send in the transaction. Okay, so this is what we need. So let's do, we have to send 5 ether. Basically we have an error here which says that if amount is 0, if it does not match the message dot value, then we revert this, and we got a deposit mismatch. Okay, Now let's call this function with a value of 5 ether. Okay, now boom, this again fails. Now this is where we have to read the docs actually well. So slash slash value, and what do we need? Slash slash value, and we need 5 ether. So what did we type? Okay, boom. Let's go and do this. And let's keep the value flag ahead. 5 ether. This again fails. Okay. Let's try to debug this now step by step. We will also use AI. I can fix this, but I want you to know that in writing smart contracts, there is a lot of a process called chewing glass, which is when you will not understand things because the data is spitted out in a random format. So you'll have to go through a lot of jargon and understand what is happening. Now let's spin up a chat GPT because that's the go-to, and cursor folks don't support me. Let's go to this chat and let's see if give it a function, and let's also give it the error that we are encountering. Okay, so why is it failing? Let's try to failing. Okay, cool. Now what is the problem here? We will be easily getting dissected in. Now the problem can be either amount is 0, which is not, or deposit is getting mismatched. Okay, which is also getting not, right? So which are somewhere like, yes, each has a unique selector. So the hash in the error is this. Why the reward is happening? Phi is interpreted as integer and not phi ether. You're sending amount. The message dot value is equal to phi ether, which is fine to away. Is this? So we have to specify amount as this. So what does this mean? So in ether, there is a lot of units, like there is rupees, there is paisa. Similarly, so 1 ether is equal to this much way and this much way. Okay, now here 5 whatever zeros means 5 ether, so we have to pass 5 because we want the contract to understand that we are passing 5 ether and not 5 way. Okay, boom, the transaction goes through. So this was a little error that we were passing 5 and this was not what actually the contract needed. Everything is counted in decimals and hence this happens. Now, no. Let's go back and let's call the check balance function. We want to know how much balance does this function has. I mean, the person has. So it is a view function, so we'll use cast call. Earlier we had used cast send as we were interacting with the contract. Now we are just reading through the data of the contract. So contract address, okay. Check balance address, and what the address is, it is the second, I mean the first key, I guess. 0D, yes, the first key. And let's go to RPC URL. There is another interesting thing that is upcoming here. So no such files or directories. Wow, okay, what happened here? We asked for contract address, check balance. I guess this should be formatted as string. Internal transport error. So we are not able to call the function which is check balance, right? This means there is some error in our function calling. What can we do here? Let's go back, and deposit was successful. Let's go back and see what deposit had. Okay, so it we calling send, we call contract address. Let's try and see if this is the problem that we are encountering. Check balance. Okay, check balance of whom. So we'll go and we will put in the value. Now we don't need a value here because this function is not payable. And let's try this, and boom, we get something here, but we don't need that, right? We just want to call this contract. So let's copy this, and instead of cast send, let's use a cast call. This is what we get. This is a bullshit amount of jargon which is not human readable. So what do? We do a little something called q into 56, which is the return time. So the data is always formatted to us, that is 5 raised to 18. This is how we actually utilize the u into 56 that we put in the contract earlier. Now final function to test is withdraw, but before that let's actually deposit some more money from another account. So we had used this key, so we will use the second key, and we'll just write key2 is equal to this, and let's call you. Don't be scared, you won't be calling the contract using this. You will be using something called scripts, interactions, a lot of things. So let's deposit 7, and private key will be key2, right? Key2. Okay, this fails. Now why does it fails? Let me load the env again, and boom, no key was supplied. So the variables need to match with whatever dollar you are going here. Server return, this is the custom error. So what's happening again? The value is 5 ether and we are sending 7 ether, so the contract will not accept this. Once you fix this, this is done. Now let's check the balance of contract. Okay, contract address and RTC URL, it is 12 ETH. Okay, 5 belongs to the first person, 7 belongs to second person. What happens when we try to call withdraw with more amount? Okay, with more amount than there is needed. Yes, this will have to revert, but then we do not have this, so amount cannot be greater than the what's being called with. Okay, and what is in there. Okay, so what we'll do is we will remove this value flag and we will just use 7 for the first depositor. Let's do that. Depositor, that was just that, and boom, we'll try to get 7 ether out of this. Hope this does not work. Yes, again it does not work. So for this, let's try a good amount of ether. Let's try to get 2 ether out. Boom, again fails. Why? Because we're calling the wrong function. So everything has to match. Your function signature, your withdraw, whatever name you are given the function signature, the amount that you have, the private key. This is what intricacies and attention to detail is. This goes through now. Now let's check the contract balance again. This is 10 ETH. So basically 2 ETH got out of the contract as his return here. So this is what a process of smart contract writing looks like. There is something called script, there is something called test, but that's all for the next contract. We can write test to test this functions. There is something called coverage, a lot more to cover in the next video. So until then, see you soon.